Good afternoon. My name is Bill Carlin. I'm Senior Manager of Satellite Solutions for AWS Aerospace and Satellite Solutions Group. And thank you for having me in today. I want to introduce my colleague Omran Almadi from MBRC, responsible for satellite and space missions at MBRC. And today we're going to talk about how AWS and MBRC are working together to apply cloud-enabled solutions to satellite missions on behalf of MBRC and, in fact, on behalf of the people of the world. It's an exciting time to be working on space. The space industry is growing very rapidly as the economics of space and satellite have dramatically shifted. It used to be a very expensive endeavor to launch a satellite, build a rocket, and deliver payloads to space, and now we see those costs declining at a dramatic rate. We're seeing the same effects starting to show up in human spaceflight, and we're seeing the proliferation, or at least the planned proliferation, of satellite constellations that will enable us to cover every square kilometer of the Earth, for whether it's information collection, satellite communications, media and content distribution, basic telecom infrastructure. This results in an awful lot of information that has to be stored, managed, processed, and analyzed. So it is a very unique opportunity as a cloud provider to work with organizations like MBRSC to maximize the efficiency of the effort. So cloud computing, very basically, is by definition an on-demand delivery of IT resources, whether that be storage, compute, or other types of IT services, on a pay-as-you-go model, so that we effectively afford the user, the enterprise, on-demand utility computing. So how is it relevant to the satellite industry? As I mentioned, space and satellite are expensive, so reducing costs is important. Space and satellite generate huge volumes of data, so managing that data and distributing it globally are critical. Space and satellite assets are expensive, and they have to be managed properly for preservation. Infrastructure supporting these missions and these assets are expensive, so we have to figure out ways to try and minimize it. So we're driving down the cost of innovation using cloud utility computing, storage, and other services on a pay-as-you-go basis. There's no longer the requirement to sign up for large capacities of server capacity, bandwidth, et cetera. This is all something that we can provision on a pay-as-you-go basis. Our network of data centers, availability zones, and data regions is global, and they're all linked together by 100 gigabit per second fiber optic. That allows for the lowest latency delivery of data to space, and the lowest from space, and the lowest latency delivery of that space-based information to any region in the world. We use artificial intelligence, machine learning, edge computing, Internet of Things processing to protect that network and protect those assets. And in providing a modern global infrastructure, we enable the user, the enterprise, the government agency to focus on its mission and not on the cost of acquisition of expensive capital assets. So what we try and do here on the Earth, we bring the cloud to the user. And first, we built our regional network. We have 25 data regions around the world comprised of 75 availability zones and hundreds of data centers, all linked together in a diverse and redundant manner. We are pushing the edge of the cloud out, first terrestrially and eventually into space through products we call Outpost and Snow. We use availability of local zones to create essentially regional or metro data centers in a very particular area, and we can extend the cloud all the way to literally a man-wearable backpack to be deployed in tactical situations, whether you're fighting fires or in a military situation, or whether you're doing it in very remote and hostile environments. So MBRC and AWS work together in a very specific application, and that is the control of a satellite and the acquisition of the data that that satellite collects. In a traditional model, MBRC, as an example, would build its own ground network. That network would contact the satellite, communicate with it, task it, tell it what to do, and then on a regular basis download the data from that satellite. That data, or that Earth station or ground segment location would be discrete, typically only one, sometimes two. And so there would be an acquisition latency of a few seconds to acquire that data, but then an additional latency to process that data either at that location or transmitted back to an on-premises data center type location. And then for the actual distribution of that data to outlets that want to use it, there would be the latency of actually moving the data from the on-premises location out to the user community. Traditionally, this could range from an hour to days of time. Using AWS Ground Station, MBRC downlinks and controls and downlinks the satellite directly from the cloud. There's essentially a one-stop low latency acquisition of the satellite and acquisition of the satellite data, which is then processed and distributed internally in the cloud. I mentioned that a typical operator might have one or two of their own Earth stations. AWS has currently have 9 ground facilities around the world, with a further 3 coming online by the end of 2022. This gives us the ability to collect satellite data on a regular and consistently fast and low latency basis. Our ground station facilities are located on the routes that the satellites typically fly. Further, they're all linked at 100 gigabits per second fiber optic. And when we work with MBRSC, they can be downloading in 9 different locations and delivering back to their data center here, all for one price. There are no extra costs. So the value proposition is pretty clear. The customer doesn't buy infrastructure. The customer is free of the capital burdens and the operation expense burdens of staffing the ground segment facilities. Further, the facilities are scalable. So as we see capacity utilization rise, we add more antennas and more processing at those facilities. It delivers directly to the cloud. So storage, compute, or other services are available on a scaling and on-demand basis. There's no pre-planning of capacity required. And as the network scales, as the data volumes grow, you achieve even greater economies of scale as costs fall. So it's pretty simple. We onboard you to our service. If you're a satellite operator, we ask you for basic information around your satellite. It's what we call CONOPS, or Concept of Operations. We ask for its international user ID, and we help you with the licensing requirements in the various countries that, or downlink locations you're going to utilize. Once set up, you can fly the satellite from the cloud, essentially fly it from your laptop. Similarly, you can schedule the passes to receive the data as it overflies these locations, downlinking at anywhere from 500 to 3 to 5 gigabit per second, depending on demodulation and coding processing. From receipt, it can be processed either locally or distributed to any facility in the world where we're located. So in short, you can lever this global network. You have all the flexibility of whether you're flying 1 or 1,000 satellites. You pay as you use it. And it allows you to collect the data in the quickest and lowest latency environment. An important distinction: quick because we have many locations, low latency because those locations deliver data at 100 gig per second. So I want to ask my friend Omran to come up and overview an actual architecture running in the cloud, flying and controlling and downlinking a satellite. Please welcome Omar Al-Hamadi.
Thanks, Bill. Good evening, everyone. My name is Omar Al-Hamadi. I'm working with MBRC since now almost 10 years. Currently, I'm leading the MRS Mars Mission Science Data Center development. Talk a bit about that in a minute. And I worked previously on developing some satellite application, developing some ground network software, some ground segment software as well. So just brief introduction about MBRC. As all of you know, we started 2006. The name was Emirates Institution for Advanced Science and Technology. And then a declare issued to incorporate Emirates Institution for Advanced Science and Technology into the newly established entity called Mohammed Baraj Space Center. That was back April 2015. And we have a clear vision and mission from the country leaderships. We would like to be a recognized center of excellence in the field of science and technology. And to do that, we need to build a sustainable science and technology field here in UAE and contribute to the economy-based and knowledge-based economy. And to do that, we need to implement several initiatives, several programs related to the space and technology sectors. Some of the programs that currently running at MBRC, the first one is we are focusing on satellite development program. So we started back 2006 developing DubaiSat-1. This is the first Earth observation satellite being developed by an entity within UAE. And we had partnered with our strategic partner from South Korea, and we had a technology transfer kind of collaboration to allow us to create the nation's capabilities to build spacecraft and build the space sector here within UAE. And then we had a couple of Earth observation satellites, DubaiSat-2 and then KhalifaSat, which is the first kind of spacecraft, Earth observation spacecraft, fully developed by Emirati engineer and was launched 2018. We have the testing, the development, implementation facility here in Dubai. So we have a huge clean room to support the development of such kind of programs. Currently, just today, we had a press conference that state the updates of MBZSat, our very advanced kind of Earth observation satellites. So this is all under the Space Development Program. Then we have the MRS Mars missions, and probably you know the launch of HOPE probe, and that was successful last year. And then February this year, we reached Mars, and we are currently orbiting around Mars. Using these instruments on board the HOPE probe, we are collecting observation around the Mars and sending that data back to the ground facilities that we have for further processing and analysis. And we're currently sharing the first data set to the science community just to make sure that the science community is involved in that mission and trying to help them understand the atmospheric around the Mars. We have the Mars 2117. It's a very long-term plan. It's a 100-year plan that was put by our leadership in order to make sure that we have a sustainable scientific programs that is running for future generations. Under this program, we have different initiatives. We have the lunar mission. The first mission will be a rover that will be sent to the lunar, collecting some data, analyzing that data. And then we have an initiative to build a Mars Science City here in UAE. And then Another program is the analog mission, where we send the crew to be in a kind of a space environment where they are fully isolated. They're doing some experiment. And the final program that we are running here at MBRC is the UAE astronaut program. Probably you heard about Hazza al-Mansouri, the first UAE astronaut that went to the International Space Station. Currently we have around 4 astronauts that are under preparation for future missions. So these are some of the programs that we have at MBRC and will drive us toward a knowledge-based economy. Okay, so why we decided to go for cloud for certain solution that we are running here at the ground segment or ground facility. As Bill explained, space industry is extremely expensive, and we decided to reduce the cost as much as possible for the things that we can have, we can run at a lower cost. Not only the cost, scalability is an important aspect of the cloud. We have some missions that collect data in terms of tera and petabyte. So we need that kind of scalability to happen as fast as possible. Reliability is an important aspect. The agility to innovate is another important aspect. We can come up with a quick prototype for a certain solution in the cloud, and that help us to demonstrate that to the higher management and make sure that we can convince them with this very quick kind of prototype. Our utilization for the cloud explain two things, two solutions that we are running currently in the cloud. The first one is the Science Data Center for the MBRC Mars mission. The main role for the Science Data Center is to act as the main data repository for the data that we gathered from the MBRC Mars mission. Just make sure that we properly manage that data, make sure it's well archived, well backed, well indexed. The second rule is to have a data processing platform that will allow us to convert the raw data that we get from the instruments to higher level of scientific products that can be shared to the scientific community for further analysis to understand the Mars atmosphere. The third aspect, of course, is the data dissemination. Make sure that whatever we gather, whatever we process is accessible by the science community. So these are the main rules of the Science Data Center. And that Science Data Center is that kind of solution is fully deployed at AWS. It's kind of entirely cloud-native solution, utilizing different managed services from AWS, including the serverless technologies, some storage services like S3, RDS, and these kind of services. We are utilizing also the compute resources, the batch processing, and the container-based services that AWS provides. And using these kind of managed services and interconnect these kind of services together, we were able to have a fully automated cloud-based data processing for the MBRC Mars mission, which is extremely innovative kind of solution that we built for the MBRC Mars mission. And utilizing different AWS managed services, we were able to build that kind of solution and make sure that this kind of solution can be applied also for further scientific missions using the CDKs, the Cloud Development Kit that we utilize. So we capture the entire infrastructure using these scripts, and then from these scripts we can build the similar environment for different missions with certain customization. Of course, we put all kind of cost into OpEx rather than having this kind of cost into CapEx. As I mentioned, we'd like to reduce the ground facility cost for our missions running at MBRC. This is the architecture for the science data center solution. I'm not going to go in details about this kind of architecture, but just I would like to give you an insight how we utilize different AWS managed services in order to come up, interconnect them, and then come up with the innovative solution that can run for a couple of missions. We have tomorrow another presentation to dig deeply into the architecture of the Emirates Mars Mission Science Data Center, how we utilize different AWS managed services to come up with this kind of solution. So this is the first solution that we have fully deployed at AWS environment. And then we have KhalifaSat, our Earth observation satellite, currently orbiting around the Earth, collecting data, and then we are utilizing AWS ground station in order to increase the accessibility to the spacecraft, in order to download the payload data to our processing environment that we have at our premise. So we use AWS different ground station that is globally distributed to download expand data. It enhances the accessibility to our spacecraft. Is very crucial, especially if we have certain urgent requests from either customers or for certain emergency. We have better access with having antennas and ground station running across the globe. We can deliver data to our customer in a fast manner. This is very crucial for certain customers. We need to send them the data that we do and we process as soon as possible. We gather them. One important aspect is that we are running that. We faced a very simple kind of scheduling of contacts, running the contacts, and then monitoring the contacts, and after that, analyzing the contacts and downloading the data. The cost very cheaper than running that kind of services on different ground station providers. We previously had different providers, but the operation team here satisfied with the AWS kind of ground station network. I think Bill explained the architecture for ground station services. During the contact, data downloaded to the AWS antennas and then get relayed to the virtual machine that we are running. And then from the virtual machine, we store the raw data into S3 and immediately get pushed to our data processing environment on-premise. So this is what I have. Thank you very much for listening to me. I think, Bill, time for questions?
We have some time for questions if you're interested. Okay, I don't think there are any questions. Omran, thank you so much for joining us today. It's a pleasure.
You're welcome. It's my pleasure to have a joint presentation with us.
Thank you. Thank you, everyone.